Okay, we're going to walk through some examples of set operations. So we are given the universal set U, which is the numbers 1 through 10, and then we have sets A, B, and C that are given. So for A here, we want to find B union C. So recall that the union is the set of elements which are a part of, in this case, set B, or part of set C, or both. So when you think about the union, you can think of or. The one thing that we have to be careful of here is that we don't repeat any elements. So notice that B has the elements 2, 4, and 6. So we can go ahead and write that down. And then C has the elements 6, 7, 8, 9. Since we already put a 6 in our union, we're not going to write that again, but we are going to add 7, 8, and 9. So this is our set B union C. Okay. Our next one is A intersect C. So this upside down U is the intersection, and that means we're looking for elements that are in both sets. In this case, not A and B, A and C. All right, so we're comparing the sets A and C, and the only elements that we're going to put in the union are the ones that A and C have in common. And in this case, you can see that that's just the number 6. So we're going to write A intersect C equals the set containing 6. All right. For C here, we have A union C in parentheses, and then remember that the C up here means complement. Okay. So just like we would with arithmetic, we need to obey an order of operations when we're doing operations on sets. So the first thing I'm going to write down is kind of scratch work. I'm going to find out what is the set A union C, and then once we have that, we'll find the complement of it. Okay. So A union C is taking our two sets, and remember the union is basically just putting them together and not including any elements twice. So the set A contains 1, 2, 3, 4, 5, 6, and then C is 6, 7, 8, and 9. And again, we don't want to include that 6 more than once. So that gives us our set A union C, which is actually all of the numbers 1 through 9. So now, when we do the complement of that, remember that the complement is everything that's in the universal set that is not in this set A union C that we just wrote down. So since the universal set is 1 through 10, and the set A union C is everything 1 through 9, the only thing that's left for the complement is just 10. Okay, so notice how when we put A union C together with its complement, we get the whole universal set. Oops. All right, our last one is A intersect with B complement. So notice here this is different from C, part C above, because the complement is only applying to the set B. Again, following an order of operations, we're going to find B complement first. So this is kind of my scratch work. Set B is the set containing 2, 4, and 6. So the complement is everything in the universal set that is not in set B. So basically all the numbers 1 through 10 that are not 2, 4, or 6. So that would be 1, 3, 5, 7, 8, 9, 10. And basically you can just take the numbers 1 through 10 and then delete 2, 4, and 6. All right, so now we want to do A intersect with B complement. The set A is up here, B complement is what we just wrote down. So if we do A intersect with B complement, we're taking these two sets that I just highlighted there again, and figuring out what they have in common. So what they have in common, let's see, they both have a 1, they both have a 3, and they both have a 5, and they don't share any other elements. So therefore we have A intersect B complement is equal to the set containing 1, 3, and 5.